In this video, we're going to talk about the addition and subtraction postulates so that we can then use them later in proofs. So if you remember, addition postulate basically just means that you're going to be taking part plus part, and that'll equal the whole thing. So the addition postulate works for segments or angles. So that basically means if I take two parts and I add them together, it'll equal the whole thing, which makes perfect sense. Remember, a postulate means something that we just accept to be true without a proof. So theorems require proofs, but postulates, we just accept it because it's so obvious. We just accept it for the way it is. So if I was talking about subtraction postulate for angles or sides, that would mean if I take the whole thing, the whole angle, and I subtract off part of the angle, I'll be left with the other part. Or if I take a whole segment, I subtract off part of it, I'll be left with the other part. So that's kind of what these are saying. So let's just look at this picture here, and we're going to fill in the blanks using the different postulates. So when I look at the first one here, this is representing the distance between A and G. So segment AG plus GD is going to be equal to the whole thing, so AD. And then BD, so BD is this piece here, plus DE. So that part plus this part over here will be equal to the entire thing, so BE. So all I'm doing here is just filling in the blank. So GD plus DE. So let me get a different color here. So GD plus DE is not going to give me a new segment that I see in the picture. So this one I'm thinking is a typo, so we should fix that. So instead of GD, let's put CD. So let's make this a CD. So that way, because if you look at this one, it's not forming a whole segment, so I can't just say that that becomes GE, because that's a different segment. So instead, let's use CD, so this, plus DE, and get the whole thing. So that's going to be CE. So you can kind of see that those middle letters are dropping. That's really what's happening here. But really, you want to look at the picture, because if I didn't look at the picture, I would have just dropped the D and made this GE, which is not the case. So just be aware of that. Looking at the picture is important. So then the next one here, we're going to take, so let me erase what I have marked here. We're going to take this whole thing, so we're going to take BD, and now we're going to subtract off CD. So that means what I'm left with is this piece right here. I'm left with BC. The next one here, we're going to take CF. So we'll take CF, which is this whole thing here, and we'll get rid of CG. So I'll be left with the other piece, which is GF. And then we have down at the bottom, we're going to take BE, that whole thing, and subtract off BC. So we'll be left with CE. And again, you can kind of see a pattern here that the repeated letters, what's disappearing. But you really want to look at the picture for these. So those are addition and subtraction postulates for segments. And then we have the same thing for angles. So if we look at the angles, BAD, so BAD, remember that middle letter is the vertex, so that's important. DAF, so DAF. So this angle plus this angle here is going to equal the entire angle. So it's going to equal angle BAF. We go to the next one here. So we have AGC. So AGC is this angle plus FGA. So this angle here. So together, that's this entire angle, which ends up being a straight line. So it ends up being angle CGF. And then the last one here, we take the part BCG and we add to it FCE. So again, we're looking at this entire angle here because we took the two parts and added them together. So we're looking at BCE. And then angle subtraction will be the same thing, except for we're going to take the whole angle. So let's go ahead and look at this. So we take angle AFE. So AFE is this entire angle. And now we're getting rid of EFC. So we're getting rid of this section right here. So what we're left with is this angle. So we're left with angle CFA. Then we look at the next one. We have BAF. So BAF is this entire angle up top. We're going to remove angle DAF. So we're going to remove DAF, which is this section right here. So what I'm left with is this angle, which is angle BAD. And then lastly, we have BCD. So angle BCD is this straight angle here. And we're going to remove FCB. So we're going to remove angle FCB. So we're removing this section right here. So what I'm left with then is this wedge over here. So I'm left with angle FCE. Or you could say FCD if you want. Either way, same angle. So you can kind of see some patterns between the letters, but again, you really just want to use the pictures for these because that's going to be your easiest way to see what you're dealing with, what's left, and what you've now created if you're adding. So that's kind of just looking at the picture, which is going to be really helpful for proofs. The other thing here is using algebra. So you kind of seen this already. I think it was in our second unit. Where we've used addition and subtraction to be able to solve algebraic problems. But let's just go ahead and review that. So the first thing that's important here is this description. So it says, suppose M is between L and M. So it doesn't say that it's in the middle, it just says it's between it. So that means I have a segment L and M. M is somewhere between it, not necessarily in the middle. And then I want to use the segment addition postulate to find x and then the length of each segment. So I'm going to go ahead and fill in. So LM is going to be 8x minus 3. MN is 12x minus 5. And then it says this entire thing is 112. So the relationship between these three expressions or these three pieces of information is that the two parts added together has to equal the whole thing. So really my segment addition postulate is just saying part plus part equals the whole thing. So the first part is 8x minus 3. The second part is 12x minus 5. And the whole thing is 112. Using this picture is so helpful. So never try to do these without a picture. We're always using a picture here. So I add these up. So I get 20x. So combining like terms, minus 8 equals 112. So that I'm going to add that 8 to both sides. So I get, 120. And then divide that by 20. So we get x equals 6. So there's the first part. Then it says to plug that in. So when I plug that in over here, it's going to be 8 times 6 minus 3. So you can just plug that in. You get 45. So that means LM equals 45. And then I'm going to go ahead and plug in to the other piece here. So 12 times 6 minus 5. That gives me 67. So that means MN equals 67. And what I should do is just verify that those actually add to 112, which is what they're supposed to. So if I check that, 67 plus 45 does give me 112. So that means I'm all set. So the next one then is using angle addition. So now you're given an angle. If this picture wasn't given to you, you would want to make sure that you have a picture. They would give you a description though, so you know like which ray is in between the two, or which ray is in the angle. So if I look, I have angle DBC. So DBC is 3x plus 7. ABC is 5x minus 2. And it says ABD, the whole thing is 61. So we want to find x and then the measure of the angles. So let's start by looking at what's in the picture. I have two parts. I don't know that these are equal to each other. They don't look equal, but I don't know if they are. So what I have to know is, or what I have to do is say, well, this part plus this part is going to add up and equal the whole thing. So the two given parts added together equals the whole thing. So it's going to be 5x minus 2 plus 3x plus 7 equals 61. And then we can go ahead and combine like terms. So we have 8x plus 5 equals 61. Subtract the 5 from both sides. So we have 8x equals 56. Divide that by 8. So you get x equals 7. So there's my x value. So now I want to plug that in. So for this first angle here, I'm just going to plug it in right up top here. So I have 3 times 7 plus 7. So 3 times 7 plus 7 equals 28. So that means the measure of angle DBC is 28. So this is 28 degrees. And then I'm going to plug that into the 7 into the next one. So this is 35 minus 2, so 33. So this means that the measure of angle ABC is 33 degrees. So plug that in. So you can see that this definitely is not drawn to scale. Because the 33 looks much smaller. But your picture in the end doesn't really matter because you just use the picture as a visual to help you set up the equation. And then once you have that, well, now I can set up the equation, solve, and then if I combine these, I should get 61, which I do. So if you add those together, it should give you 61, which is a good way to check your answer. So really, this video is just kind of a review of what you've already seen back in Unit 2 so that we can now apply this to proofs. So we're going to start seeing the addition and subtraction used in proofs, which will help us get our congruent triangles. So try to check your understanding, which again is just kind of a review of this. And then tomorrow when you come in, we're going to see how we can use this in proofs.